In this video, I'm going to introduce the link layer and LANs. Our goal basically to understand the principles behind link layer services. So we'll talk a little bit about how we share a broadcast channel and talk about link layer addressing, and then talk about Ethernet as an example of a local area network. So let's get some terminology out of the way. So we have hosts and routers, and these are simply nodes. And then we're going to have communication links between or communication channels that will connect adjacent nodes along a communication path. And these are links. These links can be wired or wireless, okay? And they can be LAN links as well. By the way, even when we talk about adjacent, does not necessarily mean they are, sitting right next to each other. So say I'm connected to a Wi-Fi access point, and that access point is in the next room. It's still an adjacent node as far as the link layer is concerned. Okay, then the message, the unit of information that's transferred at the link layer is called a frame, and this frame will encapsulate a datagram. So the data link layer has the responsibility of transferring a datagram from one node to another physically adjacent node over a link. So datagrams can actually be transferred by different link layer protocols over different links. So for example, I may be plugged into some Ethernet switch somewhere on campus, and then maybe we'll use a frame relay on intermediate links from, say, a campus network to some network elsewhere, and then we may use 802.11 on the last link. Now, each link layer protocol could provide different services. It may or may not provide any reliable data transfer over a link. So let's look at an analogy from transportation. Say I were planning a trip from Princeton to Lausanne, for example. So I could take a limousine from Princeton to JFK Airport, and then take a plane from JFK Airport to Geneva, and then take a train from Geneva to Lausanne. So the tourist who is taking this trip is the datagram, and the transport segment, so whether it's the limo or the plane, the train, or, going from Princeton to JFK, that is, that's the transport segment, is a communication link. Then the mode, how I traverse those different links, would be the link layer protocol. And then let's say I went to a travel agent to plan my trip. That would be an example of the routing algorithm. So the link layer can provide different kinds of services. It can provide at the base level framing and link access. It could encapsulate the datagram into a frame. You could add a header and trailer. You could do channel access if you have a shared medium, such as with 802.11 Wi-Fi. So there are MAC addresses, and we'll define what MAC means later on. And MAC addresses are used in frame headers to identify the source and destination of this frame. And this MAC address is very different from the IP address. Some link layers provide for reliable delivery between adjacent nodes. It's not used very much on low error rate links such as optical fiber. But on wireless links, where we have high error rates, then you might see reliable delivery. And we need this on some links because you may actually be able to catch an error on a link, a short link, well before your end-to-end protocol catches that error. So you get the performance benefit. Some other link layers provide some flow control, which is basically pacing between adjacent sending and receiving nodes. Some provide for error detection, such as Ethernet, for example. Okay, and these errors can be caused by signal attenuation or noise, and receiver can detect the presence of errors, and maybe the receiver then could signal to the sender to retransmit the packet, or it could simply just silently drop the frame and leave it up to a higher layer to catch that. Some link layers provide some level of error correction, so the receiver can identify and correct a bit error without resorting to retransmission. Some link layer protocols are half duplex or full duplex, and with half duplex, the nodes at both ends of a link can transmit, but they can't transmit simultaneously. Now, the next question is, where's the link layer implemented? Well, it turns out the link layer is implemented in each and every host on a network. And the link layer is implemented in an adapter, or which is also known as a network interface card, a NIC, or sometimes on a chip. So you might have an Ethernet card, an 802.11 card, okay, the Ethernet chipset. This would implement the link layer and the physical layer. And the card would typically attach into the host system buses. And the link layer is typically implemented using a combination of hardware, software, and firmware. So here your CPU may implement, from the link layer up to the application layer, and then you have a controller which may implement link and physical layers. Okay, and all of that would be inside your network adapter card. So when two adapters are communicating, on the sending side, the adapter would encapsulate the datagram into a frame, add any error checking bits, perform any reliable data transfer, any flow control, and then send off the frame. On the receiving side, it receives a frame, it looks for errors, does any reliable data transfer if that's part of the protocol, any flow control, and then it would extract the datagram and pass it to the upper layer at the receiving side. Now in the next video, we're going to talk a little bit about LANs and addressing and ARP. So this brings to an end this video.